The general conviction among most experts is that the speculation of how things came to be stays the basic clarification for the early times of the universe. This hypothesis joins the headway of stars, planets, and so forth, including life on those planets, including ourselves. Not traversing, it's a truly odd speculation named the Big Bang. It offers an enlightening assessment concerning what might have happened at first. The universe was thick in a short space, more genuine than a pinhead, with particles thickly dazed. From this moment, a giant effect of matter and energy happened, known as the Big Bang. This event, happening billions of years ago, set up the fanning out of vast history. However, degrees of progress in genuine information have set off growing oddities with the assumptions of this speculation. When NASA launched the James Webb Space Telescope, the best and most advanced space science observatory of all time, experts guessed that its perceptions would confirm the speculation of the universe's origins. Tragically, after a year in space, the telescope astounded experts with its ability to peer so deeply into the universe's past. The James Webb Telescope's dazzling limits have revealed innumerable galaxies going as far back to a time so old that it challenges how we may interpret the universe's origins. This discovery has ignited an extraordinary assessment into what existed before the Big Bang. One vital moment in this mission happened when cosmologist Rohan Natu, working with data from the telescope, suddenly found a galaxy from just a brief time after the Big Bang, making it the most distant galaxy ever noticed. NASA's discovery sent shockwaves through established experts, highlighting the unbelievable capacities of the James Webb Telescope. Its essential objective to change our viewpoint on the universe has only begun, promising to uncover astounding insights into the earliest periods of the universe's existence. This period, scarcely analyzed previously, holds the key to understanding the development of the first stars and galaxies. The telescope's disclosures have clashed with starting theories, revealing galaxies with attributes surpassing past expectations. This extraordinary surge of early galaxies has ignited a storm of scientific inquiry, prompting experts to accommodate these discoveries with existing hypotheses. As scientists wrestle with these disclosures, they face crucial questions about the very nature of the universe and the forces that shaped its development. Beyond the James Webb Telescope's advancements, which are consistent, it is found 1.5 million kilometers away from Earth, shielded from normal interference and cooled to nearly absolute zero by its tennis court-sized sun shield. The telescope includes a massive segmented mirror and remarkably sensitive instruments designed to reveal details of the early universe previously hidden. This period, known as the Great Dawn, happened around a few hundred million years after the Big Bang, marking the moment when the first stars and galaxies began to form. The process by which this unfolded remains a subject of intense study, with theories ranging from the effects of dark matter and dark energy to the interactions between star-forming gas and dust. The telescope's view of galaxies from the immense first light presents an unusual opportunity for cosmologists to test how they may interpret these complex components. By investigating these ancient galaxies, scientists can either confirm the validity of their current models or uncover gaps in understanding that could lead to crucial new discoveries. Initially, the telescope was expected to observe a few weak and small galaxies in its pilot studies. However, reality has far exceeded these assumptions. The telescope's early images of the distant universe uncovered an overflow of galaxies with ages, sizes, and brightness levels that challenged all estimates. This stunning surge of early galaxies has triggered a race among space experts to establish new records for the earliest known galaxies, with new discoveries emerging regularly, leaving traditional specialists in awe. Following the James Webb Telescope's discoveries, specialists and observers have rushed to study the existence of these extraordinarily advanced early galaxies. Some hypothesized that errors in the telescope's interpretation of major observations could be responsible for these unforeseen revelations. That said, the consensus remains that these discoveries represent a shift in how we might interpret the early universe and offer exciting glimpses into the potential for cosmic evolution. The new discoveries from the James Webb Space Telescope have raised key questions about the nature of the universe and challenged the assumptions of standard cosmological models. While some scientists are exploring whether these perceptions can be accommodated with existing hypotheses, others propose that they may be the first signs that the universe is far more complex and confusing than previously imagined. The real question at hand is our fundamental understanding of how the universe we know arose from primordial chaos. The early discoveries of the JWST could reshape our fundamental ideas of cosmic history, revealing insights not just on distant galaxies and ancient structures, but also on the very nature of our own Milky Way. As Mark McFadden, senior scientist for science and research at the European Space Agency, puts it, "You build these machines not to confirm theory but to break it. You really have no idea how it will break." The origins of the JWST can be traced back to the Space Telescope Science Institute, STSCI, in 1985, even before the Hubble Space Telescope was launched. At the time, G. Weir, then head of STSCI, was tasked with imagining what could come after Hubble. Despite initial doubts, Weir and a small group began laying the groundwork for what would eventually become the James Webb Space Telescope. Unlike Hubble, which primarily captures visible light, the JWST was designed to observe in the infrared spectrum, allowing it to peer much deeper into the universe. This ability is crucial for studying distant galaxies whose light has been stretched into the infrared due to the expansion of the universe, making them invisible to telescopes like Hubble. With its giant, cold, star-like mirror, the JWST became the premier instrument for unlocking the secrets of cosmic dawn. The need for the JWST was highlighted in 1995 when the Hubble Deep Field Observation uncovered countless galaxies in what was believed to be a void patch of sky. This discovery illustrated the richness of the early universe and underscored the need for a telescope capable of probing much deeper into cosmic history. After 20 exhausting years of development and a cost of around $1 billion, the JWST was finally launched on December 25, 2021. By July 2022, it was ready to begin its most crucial year of scientific observations. Early endeavors, such as the Early Release Science Program and the General Observer Program, were specifically designed to search for early galaxies. While initial expectations were modest, the results far exceeded them. JWST observations have challenged existing models of the early universe, revealing galaxies that defy traditional cosmological assumptions. These remarkable discoveries emphasize the importance of pushing the boundaries of scientific inquiry and highlight the surprising abilities of cutting-edge technologies like the James Webb Space Telescope. As experts continue to explore JWST data, they may uncover further insights that challenge and expand how we understand the universe. When the first data began rolling in from the JWST, cosmologists eagerly anticipated the results. Many had been preparing their data analysis pipelines for this moment for years. Rather than following the traditional peer review process, which often takes months, researchers chose to share their discoveries on preprint servers like AR14, a platform for research papers that haven't yet been peer-reviewed. This approach allowed for a new form of peer review to take place through social media platforms like Twitter, where mainstream experts could quickly discuss findings. Rohan Natu described this process as science by press release, and the ensuing storm of discussion was both rare and overwhelming. However, there were concerns about the potential drawbacks of this rapid spread of results. Statement Monel, a JWST project scientist at STSCI, warned that while the fast sharing of results facilitates quick dissemination and discussion, there is also the risk of overwhelming the process. The general understanding among most researchers is that the speculation of how things came to be remains the principal explanation for the early times of the universe. This hypothesis includes the development of stars, planets, and life on those planets, including ourselves. Despite its impressive name, the Big Bang offers a broad explanation for what might have happened at the universe's origins. The universe was densely packed into a space smaller than a pinhead, filled with densely packed particles. From this moment, a massive impact of matter and energy occurred, known as the Big Bang. This event, happening billions of years ago, set the stage for the unfolding of cosmic history. However, changes in scientific knowledge have led to growing inconsistencies with the assumptions underlying this theory. When NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever built, researchers theorized that its observations would support the theory of the universe's origins. Unfortunately, after just 1 year in space, the telescope amazed scientists with its ability to peer deeply into the universe's past. The James Webb Space Telescope's extraordinary abilities have uncovered galaxies dating back to such ancient times that they challenge our understanding of the universe's origins. This discovery has sparked intense investigation into what existed before the Big Bang. These discoveries have ignited intense investigation into what existed before the Big Bang. While the findings from the James Webb Space Telescope continue to test our understanding, they are opening new avenues for exploration and discovery. Many experts now believe that the answers to some of the universe's most significant questions may lie in these early observations, and that our current models may need to be revised or completely rethought. The existence of these distant, ancient galaxies suggests that the universe may have evolved in ways that were previously unimaginable. It also raises fundamental questions about the very nature of time, space, and cosmic evolution. The implications of these discoveries extend far beyond the field of cosmology. They have the potential to reshape our understanding of physics, the laws governing the cosmos, and even the origins of life itself. As the James Webb Space Telescope continues to gather data, its discoveries could offer profound insights into the first few seconds of the universe, the formation of the earliest galaxies, and the very processes that led to the rise of stars and other cosmic structures. These revelations could ultimately help answer long-standing questions about the origins of the universe and the forces that shaped its development, providing a more complete and accurate picture of our cosmic history. In the years to come, researchers will continue to study the data returned by the JWST, refining their models of the early universe and testing new theories about the fundamental forces and particles that shaped the cosmos. As the telescope uncovers more about the universe's past, we will come to understand more about the present and the future of our universe. The James Webb Space Telescope has already proven to be a groundbreaking instrument, and its discoveries will likely continue to surprise and move the scientific community for years to come.